In this module, we will discuss control center tools and technology from the perspective of an operator. We will then explain the supporting infrastructure and applications that ensure these technologies work. A typical control center operator works in an environment filled with technology, such as operator displays, workstations, wall boards, keyboards, phones, and radios. For operators who have previously worked in the field, they understand how activities such as clicking on an icon on a computer screen can result in a physical event occurring miles away. Conversely, when an experienced operator sees a system alarm or questionable value on one of their computer systems, they can visualize the condition that may exist in the field. For operators who have not had the opportunity to work in the field, it is important to understand how control center technologies like these bridge the cyber world to the physical world. To help you gain a better understanding of how control center technology interacts with the physical world, we will walk you through an actual example. In this case, we will have an operator use an HMI or human-machine interface to open a switch at a substation. First, the operator will use a monitor, keyboard, and mouse as a physical input-output device to interface with the system. Think of this as a way of telling the system what you want to achieve. The actions performed by the operator at the EMS workstation are then sent to a set of data servers. Typically, the data servers will then pass the control event on to a communications front-end server, which will take the event and send it to the appropriate destination, usually a substation. How the message gets to the destination depends on the communications path that was engineered for the location requirements. Once the message is received at the selected substation, it will most likely terminate at a field remote telemetry unit, or RTU. This final cyber component will translate the cyber message back to a physical value and send it through the substation control cabinet wiring to close contacts and perform the appropriate switch open event. You should now understand this event from two different perspectives: as the operator who takes an action on a system and sees a corresponding event in the field, and from the perspective of the underlying technology infrastructure. Now let's look at this same event from the perspective of the applications, databases, and system configurations that enable all the components to function. Let's start from the operator actions with the monitor, keyboard, and mouse. These input devices use configuration files located on the workstation. The configuration files map the keys typed or mouse actions taken to associated events in the EMS application. When the keystroke or mouse action happens, it is sent to the EMS application, which then forwards this to the appropriate database. The database then maps the icons and buttons on the operator display to specific data points in the field. Think of these databases and configuration files as lookup tables and a detailed list of actions to take when a particular event is seen. For example, when the switch was controlled, a corresponding record was changed in the database. The new state of this record is then sent to the communications front-end servers for processing. At this point, the operator action has moved from the keyboard to the EMS application, then to the communications front-end servers, which will route the performed action to the appropriate field communication lines. In order to deliver the message to the destination, it needs to be formatted into a specific language or protocol that can be routed to the field device. The formatted message will traverse the system by a routing database that will ensure delivery to the correct field location. Think of this packaging and delivery process like sending a letter to someone. First, you need to write the message in a language that can be read by the recipient. Next, you need to provide the appropriate address on the envelope to ensure it will reach its destination. The message will then traverse a system of trusted delivery methods until it will finally be read and processed when received. When the message is sent from the control center and received at the final destination, it is processed by an RTU or similar device, which will utilize its own local database to map a specific output point on the device. Finally, the operator action will be delivered as a physical output signal to the substation switch. If you are troubleshooting abnormal system behavior and working with the technology support teams, it is important you understand these underlying technologies, where they are located, and how they all work together. These three perspectives will aid you in understanding the various technical components necessary for control and monitoring tasks. In addition, this knowledge will enable you to properly report the status and capability of the system and improve the overall situation awareness throughout the bulk electrical system.